So 0-point energy basically is there's the vacuum or the void has fluctuations within that are energetic. They're vibrations. In the sense, the void is not empty. There is no such thing as a vacuum.
That's right. Originally, physicists thought that empty space was empty, truly empty.
Right.
But once quantum theory went forward, it was found that it's a result of Heisenberg's uncertainty principle that there's always some jitter going on at some deep level.
And this is what you're going for in your research, to develop a way of tapping into this energy.
Exactly. When you calculate how much energy is in there in a region of space, Feynman and others have said, well, it's at least the order of nuclear energies, even in, quote, empty space. So it's a case of trying to find out how to collect the energy.
Well, how close are you to actually getting to this, I mean, like you said, like we talked about earlier, Edison, he experimented with 1,200 different elements or materials before he got tungsten to create the light bulb. I mean,
in fact, in our proposals to our investors, we actually use the Edison story to point out, this may take a while. There are 4 or 5 techniques in principle whereby we see it might be doable. But we're still basically, anyone working in this field is still looking for the right engineering setup, the right construction to do it. It turns out that this effect in general, you get the most energy at very small levels. So it may require a lot of nanomachining or something. And so unfortunately it's not like a big fire that you could just ignite macroscopically.
Well, are you confident that it will happen, that you will be able to get what you're going for?
I'm confident that eventually we will. What I'm not confident about is stating a specific timeline. I certainly hope it's within my lifetime, and I expect it to be within my lifetime.
Have you had remote viewers look and see what this substance is, or possibly, using some of these other areas to kind of tune in?
Right.
Because it's...
Actually, I haven't, although some have volunteered that they've looked on their own and they sent me data, but it's still not specific enough.
You're looking for a material? Is that what you're actually looking for?
We're probably looking more, it's going to involve materials, it's also going to involve geometrical shapes, but also can actually involve the process. I mean, just to give you an idea, for example, the example I gave, plates coming together, that's a very mechanical thing. Right. Another case is to make arc discharges, sort of microscopic ball lightning. Right. And there you get a plasma that gets squeezed, very similar. In other cases, you're setting up bubbles in liquids with sound waves, and then the bubbles collapse, and there's a possibility that that also would release 0-point energy. Schwinger, as a Nobel Prize laureate, wrote a number of papers where he felt that could be a mechanism that might show up in some of the medicine. So all these different approaches are like wildly different from each other. You've got plates, you've got electrical discharges, you've got bubbles being created in liquid. Others we've looked at involve gases.
So 0-point energy vacuum, it's a medium that things can travel through, right? The fluctuations are kind of like, let's say, water. Or water molecules.
It's sort of like looking at the electrical or electromagnetic equivalent of the froth at the base of a waterfall. Just a lot of random motion. That's why generally we don't notice that it's there, because it's all random, and therefore any effect in any given direction is going to be canceled out by effect in an opposite direction. This vacuum fluctuation energy, which I'm concentrating on the electromagnetic part, actually there are other parts also, have all wavelengths and frequencies. So that means that not only is it wavelengths of a few centimeters or something, but there are wavelengths that are as big as the universe. So in that sense, we are not just figuratively or metaphorically, but we are literally in touch across the universe, because our atoms are bathed in this sea of energy that includes all these wavelengths, some of whose wavelengths stretch out, across the solar system or whatever.
Well, there's something behind it. There's another more subtle layer. Let's say there is this, foam that exists, and then something is generating.
Actually, this is an area that I and my colleagues at the Institute for Advanced Studies are looking at right now, because even when you say, okay, I've got 0-point energy, say, well, what exactly is that? Well, it's electromagnetic. Well, what do you mean it's electromagnetic? Well, it's got electric fields, it's got magnetic fields, and waves. And okay, well, what is an electric field? A wave in what? Right. And so, in some sense, unless you just want to draw the line and say, yeah, it's mathematically it works, I'm not going to worry about it. There are still the questions, well, obviously there's something even deeper than that, because we're not describing what the 0-point energy electromagnetic waves are waves of.
Right, exactly. And what I'm sort of getting to is this whole idea of consciousness, where you're saying that you can't really shield, or you've been able to shield some of the 0-point energy field, but you couldn't shield it from a remote viewer, so like consciousness somehow is traveling in some medium or a part of some non-local aspect that's even beyond these fluctuations.
It certainly has got to be the case. And these fluctuations are handleable by normal physics, and they appear in the textbooks and so on. But no one has a model for how something like remote viewing could really work. So obviously there's a lot more going on, even beyond what we can model.
Right, but there probably is a science, or there's some maybe more subtle medium in which consciousness then can travel, or...
It would be reasonable. I mean, certainly as a physicist, I assume if it walks, it's physics. So if it travels even spiritually, it's physics.
But even quantum theory says the observer, is maybe the center that affects everything around it. So, I mean, just by having the observer affect something means that, consciousness is sort of a center point of the universe. Each individual consciousness, let's say, is a center of totality. I mean, that's how I see it.
Well, certainly, and some physicists have really pressed that point home. Eugene Wigner was especially pressed that point that really, as long as we're leaving consciousness out, we're making a mistake, and consciousness is somehow involved in the observation process. And certainly, from a physics standpoint, any measurement which yields information to an individual, obviously somewhere along the line had consciousness involved. So it's a case of, well, just how much was it involved? And John Wheeler, who's one of the icons of physics, has made a big issue out of that it's a participatory universe, is his phrase, rather than just a remote observer.